We are now going for Virgilio that is going to speak around AKS. Okay, so Azure Kubernetes Services. So I think it's also going to be an awesome session. And we're going to have Pedro on the chat. I was also like to thank Vivian for being in the chat. Okay, moderating the session. Okay, so shoot away, Virgilio. It's your time.
Yeah, so hi everyone. Let me start this, and even before sharing the screen, I don't know if you guys have realized, but we are on the Global Azure mug thing. I don't know if you can actually see my mug properly, like a black one with Mickey Mouse. So Mickey Mouse will be joining us for the remaining of the session. So let me start by sharing my screen and getting this party started. So just tell me if you guys can see the actual screen.
Yeah.
Okay. Awesome. So we'll be talking today about AKS and apps. But first and foremost, we need to thank our sponsors so that we can give out that European Cloud Summit ticket by the end of the day. So you actually have to stay around until the end of the day, okay, to be able to get it. Who am I? My name is Virgilio Esteves. My Twitter handler is over there on the screen. My LinkedIn address is also over here, and my email. So I work for a company called Seven Word Technologies. We do consulting alongside another company called Alliance, and we have projects all throughout the world. And I'm an Azure MVP for quite a few years already, 8 I think by now, and still remember Azure as being like 3 services only. Like cloud services, which are now called cloud services V1, like really old ones. Something called SQL database back then, without all the options and without all the crazy features that Nico just showed us. And that small thing called storage, blobs, queues, tables, and so on. So I've been doing a lot of work on identity and containers, as you'll be able to see. So as of today, if we are talking about Azure Kubernetes Service, AKS for sure, first and foremost, we should know what AKS is. So AKS is a service provided by Microsoft as part of its Azure Cloud offering that makes it easy to use Kubernetes. Kubernetes is today the de facto standard to run production workloads and managing all these crazy, and I'll be using like Nick, a few weird words, like all that mumbo jumbo that we have to go through to get all the containers working and all the relation and the security. So we start by getting a lot of infrastructure automation, which eliminates quite a few of routine tasks that we would have to do manually if we were running like a Docker Swarm or our own cluster, and we'll see those changes. So it takes care of all the virtual machines, all the networking, all the storage of where to store the data, and so on and so forth. These will all be taken care of automatically by AKS. On the side of that, we have the development support. So we have IDE container support, not only on Visual Studio Code, but also on Visual Studio, both 2017 and 2019. The fully fledged one is actually obviously on the latest and greatest version, Visual Studio 2019. Using all the source code repositories that we have, GitHub, Azure DevOps, and whatever you want to use. Registry support, Helm. On our case, we'll be using something called ACR, Azure Container Registry. Already has support for Helm. We'll talk about Helm in a little bit later. All the CI/CD tools. We can talk either about GitHub, but today we'll actually make use of Azure DevOps. We'll try to get there. There's a lot of things. Monitoring. A couple of the things that Pedro already showed up today about the container monitoring and so on. You can get all of that data into Azure Monitor, and you already have some of the things directly on your AKS cluster. All the microservice debugging, we'll also take a look at that. And to finalize, very important thing, all the security services, all the governance services, all the identity management services and pieces that we are used to have on Azure on a lot of services are also available on top of AKS right out of the box. So after giving you guys, and girls obviously, a notion of what AKS is, it's important to figure out what the Kubernetes cluster architecture actually looks like on Azure to have a deeper understanding of what is the actual landscape of the service. So Azure manages all the control plane. That's all managed for us. So like all the API server, what version of AKS, if we want to upgrade the version of AKS that we are using, boom, that's all done. That's all done automatically by Azure. All the management and relationing with the scheduler and so on to get the containers running. The only things that we have to manage are things called nodes. Those nodes have kubelet on it. They have the container runtime. They have the containers themselves, and they have the kube proxy. We'll see a couple of the things in a bit. What does this customer manager managed piece translates to in case of the Azure resources themselves? So a node is actually an Azure virtual machine that has an Azure virtual network interface that connects to an Azure virtual network. So all the security features that we can have on Azure virtual networks in isolation, we can have on node relations and node deployments. And the containers make use of Azure disks and Azure files on the back without any effort on our part. How do we deploy something to an AKS cluster? This is one simple example of using something called an Helm chart. We'll take a look at those. So this is a simple Helm chart that we name, that we say, okay, we are going to run something called Nginx with a couple of labels and metadata. We are running an Nginx container. This is the image that we are gonna use. This is the container port, and these are the resource requests and limits that we want for that running container. We send that Helm chart over to the AKS cluster, and AKS cluster takes care of deploying the services, deploying the bots, getting the load balancer in front of it, and making it available to the outside world without us having to do pretty much any other management apart from that. So, and with this, we get to the networking part. Networking, we have 4 different types of networking available on AKS. We have cluster IP, no port, load balancer, and ingress. With cluster IP is used so that we can get an IP that is private to the cluster. So it's internal, it won't be available to the outside world. So what happens is that we can have a service deployed on port 80, on various spots, and the internal traffic comes over to this cluster IP, and that gets load balanced and redirected to whatever instance is available at the time. When we start using node ports consume and allocate ports on the specific nodes, meaning ports are a unique constraint. So you can have only one thing listening on port, for example, 31,000. So if we specify that we require a specific port on the AKS node to make that software available to the outside world, we can only deploy as much instances of our application as we can make available on those nodes. So if we only have 3 nodes, we can only have 3 endpoints for that specific piece. When we are talking about a load balancer networking, things start to shift, because it comes over here to a piece of a load balancer. We also have that, and it's based on an IP address. So we get a load balanced IP endpoint with a port that we specify, and that one will then load it up to the AKS nodes. There is an option of also changing the ports over here and over here on the pod so that we can have more instances than the actual nodes that we have available. Last but not least, ingress. That's where all the magic starts to happen with the DNS names. So we can have the root address or just parts of the address, redirecting on this ingress piece to different services that can be deployed on whatever internal ports that we want, taking away pretty much the majority of the limitations on the amount of instances that we can run of our container. Going over to the advanced networking. And if you get any questions, don't forget, shoot them up on the chat, and Pedro will read them out. Regarding advanced networking, as we've seen before, a node is actually encapsulates a virtual machine that has its own access to the Azure virtual network. So that allows different nodes to communicate using the Azure virtual network. Or imagine that you could have like your on-prem services connected to the same Azure virtual network, and that would allow your containers to access your on-prem systems without exposing your on-prem systems to the actual outside world right away. So for a hybrid scenario, it's all covered. It's all covered, no issue whatsoever, and we have security all around. Regarding storage have each of the nodes as a pod, and those pods have a persistent volume claim, and those persistent volumes can be either saved on Azure files, which are based on standard storage, or Azure managed disks that make use of the premium storage. And when we deploy the service, we actually can specify what type of storage we want. Scaling, which is pretty much the last piece that we will be covering here on the slide deck. Scaling, we have 2 types of scaling. One is the horizontal pod autoscaler. So we can do horizontal pod scaling manually. So going over to the portal, using the Azure CLI, or making use of the Azure ARM, so that we can get more pods associated with our scale set, the VM scale set, which is the default now when we create an AKS cluster. And it's not only the default, but it's what you should use. Okay, don't make use of anything else but VM scale sets, because we are jumping up on all the functionalities and all the awesome features that VM scale sets have. Apart from the horizontal path autoscaler, we also have something called a cluster autoscaler. So we can actually scale out the nodes also. So we can get more and more nodes right away, or even changing the amount of nodes that we have. On top of these, we can have different agent pools. So imagine that we defined agent pools, which represent this amount of nodes. Okay, so a group of nodes is called an agent pool. And by default, when we create an AKS cluster, we define what type of agent pool we want. If it's Windows, if it is Linux, but we can also define more than one type of agent pool. So we can actually have an AKS cluster with Linux agent, with a pool of Linux agents, a pool of Windows agents, and also with something called the Azure container instances. So we can also have an agent pool that can do rapid burst scaling, deploying those containers to Azure container instances. It's a super awesome feature. Azure container instances has been around for a bit now. They do start pretty fast. So it's like a pretty warmed up environment that allows us to get our containers running with anything that we ask. And now it's demo time, and let's try to cover up all the crazy things that I have to show you guys. So I won't be using my machine. We'll be using the Azure Cloud Shell out of the box. Okay, so right now I'm just gonna ensure that I have my correct sub selected, and we have an AKS cluster in this sub. So over here on this resource group, I have like a whole bunch of resources deployed, and I have like this Kubernetes service over here, which will take just a quick look to see what we have over here. So we have the node pools that we talked about initially. So this is a node pool that is running a specific Kubernetes version. It is based on the standard D2v2 VMs, and we have 2 nodes over here. We can increase the nodes right away, or we can also set the auto scaling. And this is where things start to get really, really interesting. Okay, so we can get all of that for free. We can also have node pools, Linux or Windows, but in this case, I haven't deployed a Windows authentication profile, so that's why it does not allow me to select Windows over here, but we can select other Kubernetes versions or have a pool with other sizes. So imagine that you'd want to have a dedicated pool with machines that would be able to do GPU operations. That's a perfect thing to have. And you can say, I want to deploy this service to that specific set of machines. On top of that, we also have the scaling options over here. Yeah, so we do the support for the scale over here on the portal. So this has already been fixed. Beforehand, it was possible to make the change on the 2 sides, but now, as it is a multi-node pool, it only supports doing that on the actual node pool. So we'll scale the node pools there, and we can have auto scaling defined differently for different demo pools, for different agent pools. So let's get back to our Azure Cloud Shell. Let me connect to my VM that I have over here that has a couple of applications. So we have an API application, a web application, and an init that will initialize MongoDB instance. So let me get those ones started. So we'll be starting Mongo, and I'll show you what this is doing. So this is actually creating a Mongo container and running some initialization on on that Mongo container. Guys, see my screen okay? Is the font size good? I hope so. So
your screen is okay, but your sound is
your audio, yeah.
Yeah, it's
okay,
a little bit flaky.
My audio, it's a little bit flaky. So let me just see, like, a quick thing here, just to double check.
Because it does sometimes, and then it works well for a while, and then it comes back.
It seems like my Cloud Shell actually died on me.
It seems like a network issue or something.
Okay. So let me get my Azure Cloud Shell back because it died on me.
And your sound is better now again.
Yeah, so it might be a small network issue then. Because my Cloud Shell actually died, so it was not well, and this is actually running a little bit faster now. So let me reconnect to the VM now. Okay, so I was showing you the Mongo one, right? So we are running a container, and then we are initializing the container. So if we do a Docker container ls, we are seeing here, this is the Mongo container that I was talking about. And now let's start the applications themselves. So this is just starting the two applications. And those two applications are being run directly on this VM. And they are exposed on port 3000. The web is exposed on port 3000. So if I copy the VM IP address and come over here to the browser, put up the address over here, you'll see that we have the application running. So this is the application that is running on that VM, which is making contact to the API one that is also deployed internally. Okay, all good here. This is the small output. Now let me stop those apps. Also stop. Come on. What? Okay. Demo gods. Seriously.
I think we have on the call.
Yeah, looks like.
I can while you
No, that's fine. I was just stopping. So I just stop containers, and I should not have any application running now. Just double check because I need those ports and stuff. No, it seems that it is gone now. All good. So now we'll get those and run using images. So I've already built a couple of images, which are these three images over here: content init, content web, and content API. So let me go over into a Docker start. Okay, so this is creating a couple of containers and initializing them. I can actually show you the script so that you think that I'm lying to you. Okay, so this is just doing a Docker compose with the Docker compose YAML file and the Docker compose init. What do those two files have? This one saying, okay, we want a service called Mongo. This is where we want to store the data. We are mapping a local file system location to the file system location on the container. We are doing an API. We are getting an API. This is the API, the image that we want to build. This is an environment variable override that we can connect to the Mongo instance. And this is a web app. Depends on the API. It's going to connect to the API URL on HTTP API 3001, and we are exposing port 3000 from this actual container. And what does that init do? Same thing, but it's coming over from a different location. This initializes the database. So right now, if we list the containers over here, we have the MongoDB container, which only has an internal exposed port, the API, which is only exposed internally, and this web container is exposed on port 3000. So if we now go back to the same address, we go to the very end of it to get the port there, it will show up again. And if we do Docker container log 17 -- follow logs, it is running over here. And I think I have the debug actually turned off. Yeah, I have the debug turned off, but I think I have the debug turned on the API. Yes, I do. So if you take a look over here, when we come here and for instance select sessions, you'll see that that one is coming over from data. Yeah, see over here, load speakers, and then load sessions should show up. Now let's stop all of this so that it's no longer available here. So we are now stopping the containers and removing everything. So now we no longer have anything running, not at all. Okay, all good so far?
All good so far.
Okay.
Virgilio, can I ask a question? This is not from the chat, it's actually from me.
Okay.
Do you have a Git repository or some place where we can go and check the specifics of this demo you've shown,
Yes.
so we can also test it?
Yes, I'll actually get to that at the very end of the session. I think I can get a link into the slides, but I can actually give you guys out a link for that. Okay, for all
Okay.
of that piece, and actually for a very extensive piece of documentation. We'll get to that. So we are now running. We have the code over here. We got the data. So this is the data that that came over from the Mongo instance. We can actually restart everything, and our data will be there. And now let's get to the actual AKS cluster, which is what you guys want to see, right? So for us to be able to get the cluster, first and foremost, we need to get the credentials to access the cluster. Okay, I've already done this, but I'm gonna show you how it's done and how it works. Okay, so we are doing using the Azure command, the Azure CLI, getting to AKS, getting the credentials of a cluster named. Well, it's over here. You got it. So Fab Medical VR, which lives on a resource group called Global Azure, PT 2020. So it has merged the current context. So now you can use kube control and ask get the nodes. And this is going to use the context that is set on the kubelet. And you'll see that 2 nodes will show up, which are the exact 2 same nodes that we've seen on the portal, which are over here. See, like both are ready, both are agents, and these are the versions. So it is an easy, simple way of getting access to all the nodes. And these commands also work on your local Azure CLI. Okay, so they work out of the box on all of that. So now, how do we connect to the cluster? Remember, the cluster is not, the management is not exposed to the outside world for security reasons, right? So what we do is we use the Azure CLI to perform a tunnel for us. So we can actually now do that directly from the Azure Cloud Shell. So we can do, because beforehand, this command could be executed on our own command lines, but it would not work on Azure Cloud Shell. But it has worked now for quite a bit already. So we now do AZ, AKS, browse. Now we specify the name of the cluster, which is Fab Medical VR. We need to specify the resource group, which is Global Azure PT 2020. So the container runtime used by AKS at this point in time is actually Docker based. Okay, so we'll be running Docker containers here. So let's get it started. It's going to use that, and it will set up a port forwarding over here, and we can either access these on a new tab, or it actually opened up a new tab right away for me. And this is the actual cluster. I still have, no, I don't have.
Yeah, I have a question.
Oh, I have a service. Yeah, go ahead. Let me just.
Yeah, actually, you have another option. You can create the same thing on Azure portal. So why you choose Cloud Shell to do the whole things on the Cloud Shell? So we do the same thing in the Cloud Azure portal.
Do what? The actual tunnel?
Yeah, everything. You just set up the virtual machine over here, and then you can use the ACI, and then you just use the Cloud Shell.
Mm-hmm. So I'm just using the Cloud Shell to do the demos. You can set up, like, you can create the container, the ACR and the AKS cluster and so on from the Cloud Portal right away. I actually created everything using an ARM template because I prefer to deploy all the resources at once. And as you can see, we have quite a few resources, so it would take quite some time to do that manually. And then that's pretty much, it's pretty much just that reason why I actually use the ARM template. But everything that I'm doing with the console, you can actually do from the portal.
Okay,
Virgilio?
Yeah.
Virgilio, we have here another question from Mario. related to that container runtime question he asked before. He's saying that he heard that this is not an upstream project for Docker. This is a statement. So it would be Moby runtime materialized as containerd. Is that correct?
Yes. At this point in time, yes.
Okay, Mario. So
it might eventually change in the future, but that one is so that Moby runtime is actually optimized to take the most out of all the Azure infrastructure. Okay, so getting back over here to the Azure, to the Kubernetes dashboard, so to Azure Kubernetes service. So we have something called namespaces, so we can actually separate a lot of stuff here. We can separate our applications on these namespaces, so we can isolate them. And the access to the Kubernetes cluster also is executed. It's maintained using RBAC. So we can use all the RBAC functionality and permissions and so on to control the access to the actual AKS cluster and what operations you can execute over here. So let's start from the very basic, right? Let's create something. Let's get something running. And the easiest way, yeah?
We are having audio issues again.
Okay, so I'm trying to lift my weight from the cable, but it seems that it's not working.
Do you want to try and turn off your video? See if
I can actually try and turn off my camera to see if it helps a bit. Let's see. It's a little bit better now?
Yeah, it sounds better.
Okay, so like I was saying, let's start by creating something, getting something running on the AKS cluster. So we click over here on create. We have three options, either YAML and JSON over here from a file directly or from an app here. We'll be using a container that I've built and pushed into my container registry. So on this container registry, we have these repositories, and we have three repositories over here with images already, okay? And we'll deploy one of them. So let's deploy the API. So the exact same one that you saw running on the VM. So this is the name, this is the image name. We'll have one path. It will be internal. So you recall this will only be available to other containers running in this cluster. And we'll be mapping port 3001 to the port 3001 exposed by the container. And over here, we will also be stating the CPU requirements. So we'll require 0.125 of a CPU and 128 max as a memory requirement. We set that up, deploy, boom, here we are. Okay, so it will take a little bit to come up, and I can tell you right away that it will like amazingly explode on our faces. Okay, and why is that? It will explode because we have MongoDB, but we haven't yet been able to say, okay, I actually have to store it's not MongoDB this time, by the way, it's the Azure Cosmos database, which is what we are going to use. So we have an Azure Cosmos database over here, and we'll be connecting to this Azure Cosmos database by using, it has been deployed, let me see over here. So it's using Mongo. Okay, it has been deployed to support Mongo, which is the same thing that we were running locally on that VM. and we'll be making use of this Node.js3 connection string. So of this actual connection string. But this data has to go over to the Kubernetes cluster. And while that is deploying, let me see if it is already failing. We can access the deployments. This is the replica set, and the replica set has a pod. I think it hasn't yet failed because it takes like 30 seconds to fail. Yeah, it will show up over here in a bit that it has actually failed. But meanwhile, we'll deploy the MongoDB secret. So we can come over here again, click create. And now instead of doing from an app, we'll create from an input text file, from text input, sorry. So we'll be sending over a piece of YAML. So this piece of YAML is stating, okay, let's use API version 1. We will create something called the secret. This is a piece of metadata. The secret is opaque, and this is the data. It's MTB, and this is the content. This is base 64 encoded, and we'll see the result afterwards. So let's click upload, and if we now come over here to the secret section, we'll see our new secret over here. It's opaque. It's named MongoDB, and we can see over here, we click, and here it is, our connection string. All secure. So we now see, whoa, the deployment is failing. Why is it failing? Let's come over here. Show me, why is it failing? Show me the logs. Okay, connection refused because it's trying to connect to a local Mongo that does not exist. Okay, so we need to fix it. How do we fix it? Let me connect on this one so that I don't kill my tunnel over there. And we can get the deployment that we did manually by using this small command. So get kubelet, get as the YAML, export it, the deployment of something called API, and store it on this file. And now, if we open up that file, you'll see that it has the definition of the deployment. Okay, so this is the definition, our image, the image pool policy, and all the CPU requests. I already have one over here to make it faster to get that without me typing. So what are we doing? We are just adding an environment variable called MongoDB connection, which is what our API is expecting. We are getting a value from a secret key reference with the name of MongoDB and the key DB. So right now, the only thing that we need to do is tell kubelet, apply this file, which is the final version, should it? It's gonna push it now. It says that this deployment has been configured. And now if we come over here, a new deployment will be coming up. Here we are. We have a new replica set. We have a pod. And if we look over here on the logs of the pod, it's now connected to MongoDB. So we now are successfully connecting to our Cosmos account database. All good so far?
All good so far.
Okay, so now let's get this back. So now we'll be doing something we'll be using this piece, which is the same thing that I showed you how to get the YAML and then do the deployment and update to do the deployment of our web piece. So we are getting the content API URL, environment variable with API 3001, and this is to the actual deployment. And over here, we have the service configuration, meaning we want a service on a port named web traffic, and we want to expose on port 80, and the target port on the container will be 3000. So right now, what we need to do is pretty much the same thing as we did for the other one. So cube control, in this case, we can do the create, because it's not even created now. We know that already. So save config, come on, equals true. And we are specifying the web.deployment.yaml file and the web.service YAML file. The deployment has been created, the service has been created. If we now come over here once again, we'll see that we have a web deployment, we have a new replica set over here, and this replica set has a pod that is already running. And as you can see, it also has a service, but the service is not yet configured. We can access the service directly over here. This will take a couple of seconds because it has to allocate an external IP address. And the IP address will show up over here, but it will also show up over here on the external endpoints. We just need to give it a couple more seconds.
Okay, Virgilio. While we wait for those seconds, I don't know if it's a good time to ask another question.
Yeah.
Do you know if at this moment we can see on Azure Monitor the logs that you shown on of the containers?
So over here, and I can skip a bit while that is getting done. It should be pretty much be now. Yes, it is over here now. But so there is these monitor containers over here, which uses the insights. So we can have a lot of insights on various things. So on the cluster status, on the health, and this is still a preview feature, okay? Both on the Kubernetes infrastructure and on the nodes. This is the node information directly with a lot of information. You can even see what is the agent image that it's being used, in the image tag, and so on and so forth. What is the Docker version? Information about the controllers that live inside Kubernetes. Information about the containers. We can see, for instance, on the API over here, should be getting the logs eventually. What is? Oh, because it's not exposed, obviously. There's no data. I have to get one that has data. So this is this only has the events on the actual container, because we haven't yet made any requests. And we also have information on the actual deployments that we were making. And as you can see over here on the very beginning of the overview, you can go to the Azure Monitor logs. So every single piece of logging that is getting generated is being pushed to Azure Monitor. So you can do all the craziness that you've shown us in setup triggers and whatnot.
Okay, cool.
So now we have the service over here. This is the endpoint. We can click it and boom, here we have it. So this is the service that we have deployed on the AKS cluster. And if you take a look over here, it says, okay, we have no speakers and no sessions. Why is that so? Okay, it is that so because we have not initialized the database, the content over here on the Azure Cosmos DB. So Cosmos DB has no data as of right now. That's why nothing is showing up. Come on. See over here, like nothing. Okay, that is the reason why. So let me go over and delete this web to show you a couple more stuff. I hope that I'm still able to get some more stuff. Not that much more because we have like 9 minutes. So, but let's see.
Yeah, I have a question.
Yeah, go ahead.
You set up a connection string. You just copy connection string from Cosmos DB, which is on Azure portal, and then you come over here and config and storage and secret file, and then you create a secret and then copy and paste your connection string. Only connection string, or you paste anything else?
Can you say that last part again? Sorry.
I'm asking. You come over here for the MongoDB. Can you open this one? The MongoDB.
Yeah, I can. So this
Yeah.
data is what is available on the portal.
Okay. Only this thing you just paste in the secret configuration file.
Yes, that's the only thing that I deployed as part of that secret YAML.
Okay, perfect. Okay.
The only thing that you need to be aware of is of the base, the need for the base 64 encode. Okay, but for that, when I'll show up, when I'll tell you a place where you guys can take a look at some of these pieces, you'll get all the info there. So I thought I was not actually needed to make use of all of that craziness. Okay.
Okay. Thanks.
Okay, so as of right now, the only thing that I want to show you still is, let me get back to my source over here and to my demos, into content web. It's showing how to do all of these using Elm charts. I've talked about it. I haven't yet showed you how to do that. So we'll create the charts folder over here on our content web, which is the one that we are going to deploy. Using that, we have an empty folder, and I will do Elm create web. This is going to create a templated chart named web. So now if we go over here and see what is inside web, we have a values file, a charts YAML file, a charts folder, and a templates folder. So let's first come over here to the values YAML. So as you can see, the basic piece is telling us, okay, this is a default one for Nginx. Let's change this repository, which will be the image, to content web, the one that we have. And I'll be changing this pull policy to always, and I'll show you guys why. I'll also do a name override over here to say that this is web, and the full name override is also web. Also in here on the service, instead of using a cluster IP, I'll be using a load balancer on port 80. And over here on the resources, we could do like all the resource limits and requests that we would like. So one thing taken care of, the values are taken care of. So let's take a look at what this shard file is. So this shard YAML file just has the name, the description of the Yelm shard, what type it is, what is the version of the shard, and what is the version of the application. And as we are not writing, we only have a latest version there. That's what we are getting over here on the app version. Okay, and I'll show you where that shows up also. So now we should get into the templates. On the templates, there is a template for deployment, ingress, service account, and services. So if we need a specific service account, we already have a template for that. So let me just open up the deployment because we are almost running out of time. Over here on the template, let me just search for the metadata entry. Yeah, over here. So on metadata, sorry, we'll just say, okay, I want to add annotations. And what are these annotations for? And this is important. This is the specific annotation that I'm naming role me. And I'm doing a rand alpha, which is a function that will generate a random number over here and save it up so that when I deploy a new one, it actually thinks that it is an actually new deployment that I'm pushing over. Okay, it's just to help fast track the deployment. This should only be executed for dev. Okay, remember that, dev only. And now over here, yeah.
Sorry to interrupt you. You have a question here from the Viv.
Okay.
He says it's probably another huge topic, but he's just asking, what if you don't want to expose my APIs to the outside world and I need to control access to them?
So over here, for instance, this API that I deployed, right? So the API that we have deployed here. So by the way, this is not weird, like keeping on an endless scrolling. If this ever happens to you, you just have to come over here to the Cloud Shell where you have the tunnel, stop it, and start it again. It's because the tunnel just broke, just went down, so we have to recreate it. So over here on the deployments, come on. You're not being my friend now. Seriously.
Want me to tap dance again?
Let's see if that now comes up. If it doesn't, but I'll go over these just to make you to show you one small thing, and then I can get these to deploy, and then we can take a look there. Okay, so you recall that awesome environment variable called content API URL that we had? We are now also having to define it here, right? So it's value, and I can actually reply to that question just like here over also. So if you see, we will be deploying a web container that it's gonna be exposed to the outside world, that it's gonna connect to an API container that it's only available internally to the cluster. It's not actually exposed to the outside world. Okay, and that's what I wanted to show you over there. But it seems that it might not be my friend right now.
Speaking about friends, my friend, we need
I know.
to wrap up.
Yeah, I know. Just need to do one small thing, just like actually 2 seconds. So
you have 1 minute left.
Yeah, it's enough actually. So the YAML file, we have all the ports. We just need to come over here and change to port 3000, which is the yellow one. Okay, now we have everything. We come back, and now we have all of that set up, right? And the beauty is now we only have to do helm install web, which is what we want to install, and this is over here. and boom, all of that setup, all the service configuration, all the deployment configuration, and so on will be taken care of by Elm. And if we copy this, paste over here, it's still, we see, okay, it is still pending. And whenever this external IP address is available, it will show up over here. The only thing lacking now is actually guide you guys through the place where it is, which is native. So this is my version of it, which is now on par with this one. So this is, these demos are actually based on these MCW. It is an MCW which I heavily contribute to, as you'll be able to see on the commits. And if you have like any questions, we are always on top of these. If you find any issues, just shoot us an issue over there. We are constantly monitoring all of that. Any other question, guys? I'll be around for the day also, so.
Not on the chat, so I think we are good.
Okay. Thank you so much once again for joining us. I hope you guys enjoyed today, and please, please, please keep safe.
Thank you, Virgilio, for your awesome session. So